All right, I told you I'd get a little video here for you. So solving with matrices is going to become, when you get to more complicated type scenarios and more complicated systems, not only a more efficient and effective manner, but oftentimes will be the only way you can get there. I mean, not the only way, but without doing many pages of work in that process. So first of all, before we can solve with matrices, we got what is a matrix? A matrix is just a system of organizing. And when we do, I'll show it to you in the other direction. There is a process. If I have something like this, like 3, -2, -1, 4, x, y. So this is like how a system of matrices would look. The process, and you don't have to know this now, but just so you understand where things are coming from. If I were to actually perform this multiplication right here, the way it happens with a matrix is this first item will multiply with that. So it'd be 3 times x. The -2 multiplies by the next one down. So however long this row is has to be the same as these columns, otherwise they can't multiply. So 3 times x, -2 times y, so that'd be -2y. There'll be the equal sign, and it's going to equal 10. The second equation is going to be -1 times x, so that's -x. 4 times y, because it goes, so as these go across, these go down. -x, 4y, that's a positive 4y. And then this will all equal 7. So that's how this is. So this is the x and y, and that's that. And you might say, well, how is that any different than this? It's not, and right now it's not any better, but that's what a matrix does. It just retakes something that we have here and puts it into a matrix view. So if we do it the other way around, let's convert this system into a matrix. And now what we're going to do is we're going to actually drop the x and the y. And really what I'm going to do, and it's pretty straightforward. One, make sure that it's going x, then y, then the equal sign, then the coefficient, all the number constant all by itself. You have to have these in the exact same order. If these two were flip-flopped, I would have to first make them in the right order. If I had a variable on this side, I would have to move it over. So I want all my variables on the left, all my constant numbers on the right, and then I write my coefficients in my matrix. 3, 4, 1, 2. And then as I do that, I'm going to actually put a line here because it's going to be an implied x and y, and I'm going to have 5 and 1. All right, this particular format is how we're going to use it then to solve this system of equations. All right, so to do that, my goal, my rigid is, I want to get it into row echelon form. Row echelon form would be, actually I think that's on my next slide, so I'm like getting ahead of myself. 1, 0, 0, 1 for my coefficients. And then these two numbers will be my answers. So if you remember back when I showed you how they multiply, the x is in the, right? It used to be in between here, the x and the y. So it was 1 times x, 0 times y. So it would be x equals a number, y equals a number. If I can get it into this form, it will tell me what x and y are. And here's the fun part is, it's really a lot like linear combinations. I'm going to do multiplying and adding and different things to actually find a solution. So again, there's my goal. So I'm going to rewrite this here as 3, 4, 1, 1. Oop, I rewrote the wrong equation. So this is 2y. So this down here should be a 2. Make sure I rewrite my equations the right way. So 3, 4, 1, 2, 5, 1. And what I can do is, I can do like I do when I do linear combinations. I can do multiplying by an entire row. I can multiply this whole equation by 2. And then I can multiply this equation by anything else. I can add and subtract equations. But what I'm going to do first is I'm going to say, well, my goal is to have 1 here. So what I'm going to do is I'm just going to, instead of writing it this row first, I'm going to write it this row first. So it would be the coefficients 1 and 2 for the x and the y. And then 3 and 4 for the other x and the y. And then this can be 1 and 5. So all I did was I flip-flopped those rows. And that's the reason why I can do that. So now I have 1 in this spot. Now this doesn't always have to be 0, but it usually ends up being 0. But either way, if I can't get this to be 0, at least I want this to be 1, then down below it is 0, and this one's 1. When we go to 3 variables, 3 equations, I'll show you how it gets a little bit more complicated, yet easier at the same time. So now I got to figure out how to make this 3 a 0 using the first equation. If I would take this top equation, remember doing linear combinations, if this could be a -3, then I could add it to be 0. So if I were to multiply that top equation by -3, so I'm going to take the first equation and multiply it by 3, and then I'm going to add it to the second equation. So really what I'm going to have here, and I'm just kind of going to do it down here in a thought bubble, it's going to be -3, -6, and -3. All right, -3 times 1, -3 times 2, -3 times 1. And now if I add these two together, that will be my second row. So my first row will still be 1, 2, 1. And then my second row will be -3 plus 3. That's 0. -6 plus 4. That's -2. And -3 plus 5. That's +2. Then I'm going to look and say, well, again, I got this 0. Now my next goal is I need to make this value a 1. So how can I make this a 1? I can do that by multiplying it by, I'm going to multiply it by -1/2. Negative times a negative is a positive. So as I go to rewrite this, my next step down, right, I went from here to here, there to there, then down. I'll have 1, 2, line 1. There's my brackets on my matrix. 0 is 0, and 0 times -1/2 is still 0. -1/2 times -2. Negative times negative is a positive. 1/2 of 2 is 1. And then I take -1/2 times +2. So negative times a positive is a negative. It'll be -1. And what that means is now I have sorry about that. I have now down here, this is the y value, because the first one was the x. Back up here when we wrote it, the first term was the x, the second term was the y, my coefficients. So that's the y coefficient. I have 1y equals -1. My top equation, right here, 1x plus 2y equals +1. I can take this value, substitute it in, so I'll have x plus 2 times -1 equals 1. X minus 2 equals 1. Add 2 to both sides. X equals 3. So the actual final solution, which I'll write right up here, will be 3, -1. This is the point of intersection. On a graph, when I graph those two lines over here, when these two lines are graphed, they will intersect at that point, and that would be the solution to that equation. All right, let's do another example. If we go with this set of 3 equations, 3 variables, first thing I'm going to do is I'm going to rewrite it into a matrix. So writing it across, it'll be 3, 8, 2, have my vertical line, -5, 2, 5, -3. Those are the coefficients. 0, 1, 2, -2, and -1. So there's my matrix. My goal will be to have a matrix that's in the form 1 and then 2 numbers here, which could be A and B, doesn't really matter. 0, 1, some other number, C. 0, 0, 1, a line, and then I'll have 3 numbers here. And when I get it in that format, I will know that this right here will be my answer for z. Because up here, it was the third coefficient, x, y, z. X, y, z. I'll have z equals something. I'll take that, plug it back into here, and that'll help me find b. And I'll take those 2 numbers, plug it in here, and that'll help me find x. So I'll have x, y, and z. So right now I've got these 3, and that's my first goal, is getting 1 right there. Well, here's a 1 right here, so I'm going to rewrite it as, I'm just going to move this row to the top. So I rewrote it there, and I don't know why I moved that one to the bottom. It doesn't really matter, as long as this is the top row. Next thing I'm going to do is I want to make this a 0. So how do I make that a 0? All right, well, I got to take this top equation, multiply it by -2. And then I'll add them together. So again, my thought bubble here as I'm going along is multiply that by -2. So multiplying across -2 times 1, -2 times 2, -2 times -2, and then -2 times -1, which is +2. Like distributive property, -2 times 1, that's -4. Negative and negative is a positive. Negative and negative is positive. Keep track of your positives and negatives. And now I'm going to add this row, or this new idea, to this second row. And when I do that, I'll move over here. The top row stays the same as 1, 2, -2, and 1. -2 plus 2 is 0. Down here, -4 plus 5 is +1. Then I have 4 and -3, also a +1. And then 2 and 0 added together is 2. Now, double bonus here. Not only did I get rid of the 0, but this is now 1. And again, my goal is 1, 1, and then the third one is a 1. I still have my third equation there, 3, 8, 2, -5. All right. I need to somehow start with making this a 0. How can I make this a 0? If I take the top equation and multiply it by -3, so times -3. So I'm going to write it down below it here. So that would be -3, -6, +6, -3. Again, -3 times 1, -3 times 2, -3 times -2, +6, -3 times 1. Add these 2. One, 2, -2, 1, nothing changes there. 0, 1, 1, 2, 0. Those add up to 2. Those add up to 8. And these add up to I just noticed I made a mistake. Not a big deal. That's a -1, and I wrote it over here as +1. So that's negative. And that means when I multiplied it right here, that should be a +3. So +3 plus 5 down here gives me -2. All right. And again, go back up here. What's my goal? I want this to be 0. If I take this equation, multiply it, because these are zeros, if I multiply this equation by -2, so times -2, I just rewrite that down here so I can see it. -2 times 0, -2 times 1, -2 times 1, and -2 times +2 is -4. negative 2 times 0, 0, negative 2 times 1, negative 2, negative 2 times 1, negative 2, negative 2 times 2, negative 4. Add these two lines up. And I will have over here 1, 2, negative 2, 1, 0, 1, 1, 2. And now when I add those two up, 0 plus 0 is 0. Negative 2 plus 2 is 0. Negative 2 plus 8 is 6. Negative 4 plus negative 2 is negative 6. And now I am almost to the goal of having a 1. How do I get this to be a 1? I divide this row by 6, resulting in this equation. 0, 0, 6 divided by 6 is 1, negative 6 divided by 6 is negative 1. So now I have this, and now I have this value, which means z equals negative 1. If I take this equation and rewrite it down here, I will have y plus z equals 2. How'd I get that? 1y plus 1z is equal to 2. Z is equal to negative 1. Y minus 1 equals 2. So therefore, y equals 3. And then if I take this equation over here and rewrite it as 1, so again it's 1, 2, negative 2, 1. So x plus 2y minus 2z is 1. X plus 2y minus 2z equals 1. And I did the same thing again. I look up here. This was negative 1 because that was the row, negative 1, negative 1. I keep making it a positive accidentally. Good thing I haven't used it yet. Still a negative 1 right there. That should be a negative 1. That should be a negative 1. Which means this right here is a negative 1. But either way, I will take these two values and substitute them in for z and for y. So I will have x plus 2 times, I said the y was 3, minus 2 times, and the z was negative 1, equals negative 1. Pay attention, negative times negative is a positive. Oops, and I see I made another mathematical mistake. Negative 2 times negative 1 is not positive 3. It is positive 2. Which makes this 8, which makes this, I should use the erase tool, makes it negative 9. Final answer. These three lines will intersect in a three-dimensional plane at negative 9, comma 3, comma negative 1 in a three-dimensional space. And that would be the solution to 3 sets of equations and 3 variables. I had a 2 in it. This was the problem that we worked on before, where we had A, B's, and C's. It is possible you could set this up into a matrix, but we would need a 5th equation. And we don't have a 5th equation, we only have 4 equations for 5 variables. So the green dot means that was this one here, 20 plus C equals 25 plus D. To do a matrix method, I would have to take these and move all my variables to the left-hand side. I could do the same thing here, here, and here, but I need a 5th equation, and I don't have one yet. So my 5th equation is going to be, if I were to look at this equation and say everything going in and everything going out. So if I were to look at this and say everything going in, et cetera, I would have E, which is x5, is going in. Look up here, I have 20 going in, so plus 20. I'm talking into the whole system. So this is going in, this is going in, 25 is going in. Down here, 25 is going in. And that will equal everything that's going out of the equation too, because you can't have more going in than going out. And you could set up another equation, and then you could work through that and make matrices to solve it as well. I'm not going to do that right now because I said I'd try to make this a short video on matrices. So process procedure is, my goal is, no matter how many variables I'm using, is to have this as 1, 1, 1, 1. And then that will give me whatever's on the other side of that line. So this would be 4 variables, so W, X, Y, Z as my equation. This number down here would tell me my Z. I would have some values here for each of those to then remake equations, substitute values back in to find the final solutions. So what a matrix does in a scenario like this is just a very, very organized way of doing linear combinations. So when you have multiple lines and trying to remember which one goes into which one where, this would be a more systematized approach to finding a solution.